Hello everyone, how you all doing? Welcome to elbwire. My name is Thorsten and I'm the founder, and I'm going to show you how you can optimize and plan your projects with our simulation tool. So let's start either from elbwire.com, where you can just click on login on the top, or you go directly on app.elbwire.com and then you log in with your login credentials which you created earlier, and then you're ready to go. So first view you see all your projects. So these are projects I've created prior to this session. So for example, I have two projects. One is a bus depot planning, which is in progress, and another one is a photovoltaics planning project, which is already done. So here you can see the status of the project. You can also filter for it, like you want to see it which are in progress, which ones are done, or in draft where I don't have any projects right now. So you can structure it, especially once you have more projects. It helps you to get a better overview. And from here you can directly dive into your project. Either you go into the project itself, so on the ones you want to continue working on, or for this case we're going to start a new project, so we just click on new project, as easy as that, and a new project is created for you. Here you already see the name, new project. You can change the name, we will do that later. So you organize all your projects. Then how does it work? On the overview you see on the left side all the input parameters, so this is the most important part for modifying your project and what you want to do. And then you have some more tabs and options I will go into later. So first thing is to define what do you actually want to optimize. Predefined is total cost of ownership, so if you want to calculate a whole business case for a project, but you can also optimize for minimal investment cost or yearly cost. So let's select investment cost for now, just to show you that you have different options, but you can also optimize for the other two things, criteria later. Then to have an overview of the different elements, so everything our software covers. This reaches from mobility, so vehicles, buses, everything in this area. Then there's charging infrastructure, so very important, what kind of charging stations, and all topics in that aspect. Furthermore, grid connection is important. Without electricity from the grid, no vehicles can be charged or no photovoltaic energy can be fed into the grid. Maybe a stationary battery is of relevance since you want to do some peak shaving for projects, or want to save your photovoltaic energy for later, or photovoltaics itself. In the standard, when you create a new project, everything is deselected to have a better overview. But let's say we want to plan a project where we want to simulate a fleet manager which wants to convert the fleet of the company from combustion engines to electric vehicles. The fleet manager already knows he wants to convert 12 vehicles, because these are the current vehicles using, and wants to know what kind of charging infrastructure is the best and the most efficient, especially for the investment cost. So first, selecting existing or decided mobility, because he already knows what kind of vehicles he wants to put into the fleet. In future it will also be able to define what kind of fleet composition is the best, but this is coming soon and still in development. So let's go into the groups. I said there were 12 vehicles, but maybe it's two different groups. One is most of employees, and there's another one of so two groups. And in the one is 8 vehicles, so these are most vehicles, and the other one is 4. This might be the salespeople, which have to drive a lot, so they have different user behavior. Of course, it's also possible to create more groups, but for now we say we go with 2. Then it's important to define what kind of vehicles they have, because this affects how much range they have, what is energy consumption. So let's say for the group of 8, we choose the most sold vehicle in Europe, electric vehicle in Europe for now, the Tesla Model Y. And for the other ones, the salesperson, we choose let's say Mercedes EQ, where we can also see all the details. What does it mean? The Tesla Model Y long range, it has 11 kilowatt AC charging, on average 124 kilowatt DC charging, battery capacity, range, and we can also do some remarks, and we can also modify it, since if we say this is not what we actually have, but we think we have a lower range, higher consumption, or there are vehicles which are not in this list, so it's also possible to create new ones. But let's stay for now, we choose these 2 vehicles. So we see it here, which we selected, and we also want to modify the mobility behavior, since they don't have the same hours of work. The standard configuration is a normal workday. Some people arrive at 7, latest at 9, and departure time is 4 p.m. to 6 p.m., 12,000 kilometers range, and they are there all days, working days. So this, let's say this is fine for us now. But the second group, the sales people, we know they will drive more. So let's say they drive 20,000 kilometers a year, and they arrive later because maybe they already had their first meeting in the morning, and we can always define a range or a certain time. So if it's 7 and 11 in the simulation, some vehicles will arrive at 7, some at 7:05, some at 10:30, and some latest at 11. So to not have it too static, we give a range to take into account all this uncertainty. For the departure time, maybe they often have to go to other earlier meetings, so they usually have to be ready at 2 p.m. So we say exactly they leave at 2 p.m. and to be able to go to next appointments. Charging below SOC, so this means if the battery status is below 30%, they would try to charge. If it's above, they don't charge. But we want them to always charge, because they always want to have a good feeling of a fully filled charged battery. So we choose 100 and say Friday is a day where they're always on site. You can create more groups as you like. This is just demonstration, and this is the power of the tool, that you can adapt it to your specific needs of your use case. So we save this. Here we see that we have various times. Not to have it overcrowded, it just says various. And to give an even better overview, we collapse it so we have a better overview. Vehicle charging target is pre-selected at 95%. This means the simulation optimizes that it always at least 95% of requests. So a vehicle wants to charge in the simulation actually can charge. 95% is reached to be efficient. Let's have it at 95% for now. Besides mobility, of course, we need charging infrastructure. This is the whole target of this case study. So we again have new charging infrastructure. So if you're planning new charging infrastructure and want to know which ones is the best, and also you can select existing charging infrastructure already planned. So a lot of projects don't start from zero, but they already have some preset definitions. For example, pre-select is one 11 kilowatt charger. Maybe there was one charger and for a test, and now they want to roll it out until all vehicles. So let's keep it at one charger, which is already existing. but we also want to create more charging stations because we want to charge all these 12 vehicles and have a high availability for the employees. So we see here standard definition is 0.5, but this is not enough since we will have up to 11 more charging stations. Since we said 12 vehicles, one charging station is already there, so it might be reasonable to say, okay, I want to set up to 11 charging stations, and I want to consider AC 11 kilowatt, 12, 22 kilowatt, and a DC charger of 50 kilowatt, which could also be interesting. Then I can look at the details, what actually is behind it. Let's say the 11 kilowatt charger I selected, so it has 11 kilowatt AC charging, total power also 11. It cannot have charge more than the one outlet. The price for this one is 1,500, and then installation cost and other costs for the installation are 2,000 euros, plus yearly cost of 150 for maintenance and maybe internet connection. So these are predefined values, but it's always possible to modify it up to your needs. Maybe you already have an offer from a wallbox supplier, then you can implement all these numbers in here, and you can also create a new one if you want to have your specific charging infrastructure. You just define what you want to do. So let's keep it like this. There's also a 100 kilowatt charger, which we maybe could select. Maybe you want to consider this, could be interesting for the sales personnel, but let's just select it to see what happens. So we selected what kind of charging stations could be optional. So we see here the small light, so it will optimize between 0 and 11 charging stations, and it will optimize between all these kind of different charging stations. The existing number is 1, but one last step we need to do before starting the simulations. We need to select a grid connection, because without any electricity from the grid there won't be any charging taking place. So let's select an existing grid connection. 50 kilowatt is maybe a bit too few for a company. They usually have more. 50 is like a not private household. Let's say they have 150. Here again, this is existing already predefined. If they want to select new grid connection, if they want to have a transformer, it's always possible to optimize for that, but the 150 could be sufficient. Otherwise I need to look into that later. We have more options. We can select the price, but if we only look at the investment cost, this is not very relevant. So we have already defined our first set of parameters. So let's go and just push this button and the optimization starts. So what is happening now? It's now simulating different configurations. So a few with one charger, another one with 10 chargers, one with a mix of 11 kilowatt and 20, another one with 11 and 50, some with only 100 kilowatt chargers, and the AI is optimizing it so it finds the best solution for a given input parameters, which in this case was low investment cost. And we see that the simulation is already done. Now it's processing the results, so we get a good overview of what is happening in the simulation. So here we see the result. Investment cost for this case is 18,100 euros. 97% chargings were fulfilled, so it's in line with the target we defined for the mobility, the 95. And we see the optimal configuration is 2 11 kilowatt chargers and 2 22 kilowatt chargers. So we have our first simulation. First results, we can look at the details, so what is happening, and we see here, for example, an average week, and what is happening here is each time the line goes up, a vehicle starts to charge, so it takes energy from the grid, and then you can see a second vehicle charging, another vehicle charging, until they are full. Then they reduce the power they need, and it goes back down. So this is taking place in simulation in the background. Why does it look different on each day? It's because there's a random factor. So we said in the beginning we defined a range. Some vehicles arrive at 7, some at 9. Some are maybe have empty battery. So each day is different, and there's always taking into account all this uncertainty. We can see this chart. We can also select the longer. We can select the whole month. So we see during the weekdays vehicle charging, then there's a weekend, nothing happening, and so on. We can have a table view, so we see all kind of events, what is happening at which exact time. So what is the power in the charging hub, in the grid, and we can also show for incidents. So these are when vehicles are not charging. So when something goes wrong, so we can see what's happening. For example, 3 times Mercedes EQE could not be charged. Once on January 3rd, 17th, and the end of January. So this is all happening in the background, and we can use this data to make analyzations, and also it's possible to download the log file, so to have a CSV file where it's possible to see all the events. If you want to do your own analysis, want to present the results, you can have a look at all of this and analyze it. So furthermore, you can export the results, so you also get the configuration if you want to save it and work on it. Or what's also very practical, you can save the configuration if you want to work on it later. So let's say my first optimization, I save it, and it now is saved, appears in my favorites, so I can always go back to it and work on that later. And I can compare it with different ones. I didn't do a different configuration for now, so let's do a second one. As you see, there's a lot of opportunities what you can modify, but let's say what happens if I want every vehicle to charge each time it arrives at the charging point. So we just modify this, but you can play around, change all kind of parameters as you like, and find out different results. So we do this again. We have another simulation taking place in the background. This usually doesn't take longer than 30 seconds. Maximum goes up to 2 minutes if it's very complicated. But usually you should have a quick response in a few seconds, so you can continue to work on it. So again, simulation is almost done. Results are processing, and in a few seconds we should have the result for this configuration. Here we go. So we have the results. As you see, 100% charging requests were fulfilled, but also we need more charges for this, which is makes sense. But here we can exactly analyze what is the effect, if it's worth to aim for the 100%, or if 95% might be enough. To compare them, let's save it. We name it my second configuration with 100%. So let's save it, giving it a name which actually explains what we did. Then we go to favorites. So now we have both simulations, my first optimization and my second configuration with 100%. Here we already see the difference in investment costs. So the second one costs more than 6,000 euros more because there's more charging stations needed, and the successful charging rate is around 3% higher. So this is the question, if this is worth investing more, or if I want to go with 4 or 6 charging stations. So this is what you can do. This is just a basic introduction. showing charging on mobility and grid connections. In future videos I will show more about stationary batteries, photovoltaics and other features and options. So before we go back to the dashboard, let's give it a name. My first project, let's put it in draft mode, and we can define a client if we want to, but let's save it. So the project is saved. We see we have 3 of 5 projects. In the essential plan we have 5 projects which we can have at the same time. Now we have 3, so we still have space to create 2 more. Let's return to the dashboard, and here we see now we have the 2 projects we had before plus the new project, which is now in draft mode, created today, last updated also today and a few minutes ago. And so then I'm done. I have my first project. So thank you very much for your time. Hope this helped you in optimizing and making efficient projects. Let me know what you want to learn next, what kind of features you want to understand or are missing. So looking forward to talking to you again. See you next time.